haven't done anything wrong then. It's like the Uno game where you have to catch someone. You're welcome. Thank you for catching me. All right. I was impressed when I got myself yesterday with the numbers I remember. And then here, that's what I get for being so overly confident. Okay, so let's go back to that. Thank you. So we're putting the -2 in for the x value. So 3 times -2, and then -7. So I just have to do the math there. I'm going to do order of operations, which means I'm going to multiply before I subtract. So -6 minus 7. So y is going to end up being -13. So hopefully you guys got that as well. So essentially what's going on here is we just found the x and y for the solution. So if I wrote that as a coordinate point, this would be -2, -13. If I were to graph those two equations, that's where they would cross. So there's kind of a lot going on there. So what we learned yesterday, we could use that method today. But we have to graph everything. Like I said, you're probably gonna like, you probably like this method a little bit more, especially if you didn't like graphing very much. So we can still do graphing. So solving system equations, graphing is one method, like one way there. Substitution that we're going to learn today is another way to get there. Tomorrow we're going to learn a third way. That probably will be your favorite method, but it's dependent on kind of the way this equation is set up. Now, for graphing, just to kind of review, we want both equations in y equals mx plus b. So that was graphing yesterday, and you'll have to do a couple of graphing problems on your homework tonight just to kind of keep that fresh. So again, that's why I told you guys to hang on to your graph paper. Those will be a few review problems that we'll have assigned tonight. So this new method we're learning today is substitution. And like I said, for the most part, you'll probably like it, I think. It's very like logical and like kind of use the same process every single time. And we'll talk about how to do that. So there is, what is that, 4 or 5 steps there? 4 steps. And I kind of have a lot of space there because I'm going to have to say a lot of things about it. So I'm kind of worried, but then hopefully the math will make some sense for you guys. So when we're doing this method, we want to have at least one variable alone in one of the equations. So that's what we're going to write first. So we want Now this first step is probably the step that is most important for this. If you don't do this step, the rest of the method won't work. So getting that one variable alone in one of the equations is going to be really important. Now, in this case, we have a variable alone. We have the y alone. So we have y equals this expression here. So we have step 1 done for us in this case. Now we'll get to problems later on after like our break today that aren't that way. So that step 1 is done already. Yep.
Are we outside for a walk?
I don't know, maybe. Is it
really
really chilly?
No.
It's warm enough? Okay, maybe we'll go for a walk, but I still want to do a few problems on the whiteboard, so we'll see where we're at. We should be able to do both. All right. So once we have a variable alone in one of the equations, we're going to replace that variable in the other equation. So if you guys look, I see that y equals this. y equals 4x minus 6. So in the other equation, in place of y, I'm going to put 4x minus 6. It's like the word substitution is the same idea. Like, so right now Mr. Hatfield's out and Mr. Smith is here and he's substituting for him. He doesn't quite look the same, but he's standing in place of him. So he's there, you know, working in place of him. So this is substituting in. That don't look alike, but it works the same way. So that's our step 2. So we're going to replace the variable in the other equation.
Your best friend is here.
Is Mr. Donahue's here?
No,
Oh, Miss Miller. She's second. So replace the variable in the other equation. You need to use parentheses. So we're going to replace that equation, or replace that expression. So in this equation, I'm going to rewrite it, and using parentheses, I'm going to get rid of that y. So instead of y, I'm going to write 4x minus 6. So if you notice, in this equation, the same equation's written, but in place of y, I just put 4x minus 6. Now the reason why this is so good, if you look at our new equation that we wrote here in the green, is everything only has an x variable. There's only the one variable. So that's what we're kind of hoping to get. We want to get it down to just a single variable. So we're going to solve this new equation. Solve that new equation. So I'm going to use parentheses first. Sorry, I'm getting a little bit ahead of myself. So we're doing our normal steps of solving. So we're going to distribute to get rid of those parentheses. Kind of taking us back a few chapters. So I distributed that 3 in. So now we need to solve for x. We combined like terms there. We're going to solve for x. Move this 18 over. And then we just have to get that x alone, so remove this 17 over. So 17 divided by 17 is just 1. So we got our x value. Now that did actually probably take a little bit more time than if we maybe had just put these 2 lines on a graph, but at the same time, if you look at that second equation, getting that second equation in slope-intercept form would be a pretty tough step to have to do. So we found x. So why are we not done yet? Why do we still have step 4? What do we need to do? We still need to find our y value. So we found our x, we still need to find y, because we need both x and y. So now that we know what x is, this becomes like the warm-up question. So now if I know x, I can substitute that back in to find our y. I typically use the top equation, the one that where we got the y all alone, but we're going to find that other variable. So we're going to take that x equals 1 and we're going to put it back into that very top equation up there, and I'm going to rewrite that equation because it doesn't show up on my board right now. So this was that equation where y was already alone. I can now put this x in, just like we did in the warm-up question. So y ends up being -2. So we found our x and we found our y. Okay, let's do another problem and then we will, we're gonna grab whiteboards. So, because I wanna make sure you guys are kind of getting this. We'll do another one together before I have you guys do some practice on the whiteboards. So in example 2, same idea as we did before, where we want to get a y alone, or we want to get a variable alone, and the y is already alone here. So just like we did last time, is if this is what y equals, I'm going to put that in place of y in the other equation. So I can substitute that in. So in place of y, now this time, I don't have to really probably bother to use parentheses because there's nothing being multiplied to y. So if you wanted to use parentheses, you could. You don't need to though, because there's just like a 1 times the y. So I'm just going to write it again. So I replace this y with what y equals, the -4x plus 12. So in this case, there's no distributing to do because nothing is being multiplied to y. So I'm ready to combine those two. So I'm going to move that 12 over. And then we'll divide to get rid of that -2 and find out that x has to be 5. Now we're not done when we get x equals 5. Remember, we still have to go back and find the y value. So we have to take this x and put it back in up there to figure out what y is. And again, I like using that equation that already has the y alone, so that I don't have to do quite as much algebra to get my y value. So it's -4x plus 12. So we're going to put 5 in as our x. So y ends up being -8, I believe. And we did go through that kind of quickly. That's why I want to pause right now and take a minute to go through these using the whiteboards. So if you guys could grab a whiteboard marker eraser, it'd be great. Do a little practice with these. And make sure you got this before we make it a little bit more difficult. Hi.
Hi.
You seem frazzled.
I am.
Okay, I'll come. All right. Okay, so guys, we're going to do some problems here with the substitution where you guys should be finding x and y. So if you guys could have your whiteboards handy here, we'll do that. Okay. So you might need calculators because some of these numbers get a little bit bigger, but not too large here. So like you guys to try this problem and find your x and y. If you want to find just one of the variables first and check it with me, that's fine. So the y is all alone. You're going to substitute that in to find the other variable. So remember, this is where we're taking this and putting it in place of this. Let me know when you just started. So replace the y though, so the y should be gone. So you're going to distribute that 7 in. So when you replace the y should disappear. And again, if you want to check with me once you found the first variable, we can check that to make sure you're not doing something wrong, because that's frustrating when the one's wrong. So you're good, and then go with your second one. Good. Be careful, there's a bunch of negatives in this problem. So we're going to combine those guys together. This one's not going to have an x because that's just 7 times 3, so let's get rid of that. So just 21 there. I think it's a negative 3 here, sorry. That's my,
oh, I didn't
so
know.
no.
Hold on.
Yeah, that changes everything, sorry. Okay, so you're going to distribute negative x, so negative, negative, it's going to be positive 6. There you go. Sorry, that's a little bit tricky. Here. So you replace the y here, and then we're going to distribute, so this is the 7x. So the y goes away, so it's going to be 7x, or negative 7x. There you go. This one maybe was a little bit tricky to start off with, sorry. Your x, the only thing is this should be a negative, which then that changes this answer. So that'll be a positive there. Yes, this will be a negative 6 then. Yeah. And then you want to put that back in. Only thing is, this is kind of tricky. When you put this back in, it's a negative x, so this will end up being a positive 6 here, because it's 2 negatives. You got it, good work. You got it, good job. Only thing, no, you only did a small mistake. So 5 minus 7 is just negative 2. They're on the same side, so you just combine them the way they are.
Okay.
You're good, Hope, good job. Yep, you got your first one there. You got your first. And then, yeah, just do that, and that's your y value then. Good, go ahead, Nicholas. Good work. A little bit rusty, but then we got it. Yep. So, put an extra 7 in here for some reason. Should be 7 times x and 7 times 3. So I don't know where this extra 7 is coming from. And I think this is, let's just do another one. We'll get you guys going on another one here. Let's try a little bit easier one. Let me find a better one. That was maybe a little bit hard to start off with. Let's see. There's a lot of negatives in there, which is confusing. I know. All right, let's try a new one. Sorry, I probably should have done that one on the board. Sorry, those of you guys are online. I'm not going to talk through that one. I'll do. Let me try. Is that little line really bothering you? Okay. All right, this one does not have negatives. I don't want you guys to freak out about those. So let's try this one. So y equals 3x minus 2, and then, so you're replacing the y with what you know y equals. Yeah, no. Yeah, that'll be 7x plus 4, right? Then I move that over. Is this one better? This one you guys don't hate me on? Yeah, yeah. So I subtract, I move that over, so you're going to subtract. You're almost there. You see, you put that x and 6x together, so how many x's would that be? Yeah. Yes, I believe. Yeah. So you're replacing, you're putting this in place of that. Can you do that? No. Just How we doing, you guys? Looking good? Seeing lots of good, yep, good stuff. How we doing? So, oh, we did it already? Okay. So, all right. I think we're doing okay, right?
So are we gonna make a lap now?
We can do a lap in a second here. Let me just go through this one. I'm going to do one more with you guys before we go outside though. So this is going to replace this y, just in case you guys didn't get there. Then I have to distribute here, so remember we're multiplying. Combine these together. And then I have to move this 4 over. So we end up finding out x equals 1. And once we know that, we can substitute that back in to find our y. I want to show you guys one more, because all the ones I've showed you guys so far, the y has been alone. And that might not always be the case. So let me show you guys one where x is alone. And show you guys you can also solve that kind. So let me show you that now. I'm going to decide which one to use. Okay, let's try. Let's try one more before we take another break. Take a break. Okay, so this time, you guys, instead of y being alone, x is alone. That's okay. If x is alone, now use x to replace x. That makes sense? So now we know what x equals. So instead of replacing y, this time we're going to replace x instead. So you have to put that in place of x this time instead of in place of y. Yep. And I'll kind of check as you guys are going here. Only thing is you're missing the Heather, you're missing the minus y behind.
I did that.
So yeah, sorry. I just didn't want you to get through it and then find that out. Okay. Yeah, you're good. So now you're gonna, but you're replacing x, so x should be gone. So you're gonna distribute that. Remember, x is gonna go away this time. Okay, so this is gonna go in place of x this time. So this is what x equals, so I'm gonna put it here instead. So this one's going in place of x instead. So distribute, yep. Yep, yep. There you go. Maybe just subtract. This would be 4y minus y, so that'd be 2y. There you go. Good work. Careful, this should be a 7, right? Some sort of magic happened in your calculator. Yeah. How we doing? Yeah, good work. So now this time after replacing, very good. We're replacing x instead of y. Oh, careful. 4 minus y is 3y, right? Yep, so this would be 4y, and then you're going to, this should be a minus y. You see that up there?
Yeah.
They're on the same side though, so you subtract it. Sorry. I know it's confusing. Yep, so add those together. You're doing good. You're good. Yep, that's it for your x. There you go. Good work. Yeah, good work. There you go. I think it's 7. 21 divided by 3. So when you're done there, guys, you can start cleaning up your boards. I think most of you guys are almost there. Let me kind of get us going through. I'll keep. Jaden, you're good? Okay. x is fine to substitute for as well. It's whatever is easiest. So I have 4y minus y, so I have 3y. They're on the same side of the equal sign. That's going to equal 21. Divide by 3, find out y is 7. Once I know y is 7, I have to substitute that back in to find x. So I find out x is 9. All right, let me put this online quick, and then we can go outside for a walk. And we'll